A lockout-tagout program is crucial to workforce safety, and lockout-tagout failures are a leading cause of severe injuries in the workplace. Lockout-tagout, or LOTO, are requirements by OSHA that mandate employers to establish programs to protect workers from accidental energization or release of stored energy during maintenance by implementing procedures for employee training, machine-specific lockout/tagout policies, durable and standardized lockout-tagout devices, and annual program audits. The OSHA requirement that covers lockout-tagout is 29 CFR 1910.147, titled the Control of Hazardous Energy. This standard applies to general industry workplaces and outlines the procedures employers must follow to protect workers from the unexpected release of hazardous energy during maintenance and service activities. The core lockout-tagout process involves preparing for shutdown, notifying employees, shutting down equipment, isolating energy sources, checking for stored energy, and verifying that isolation was effective. Hazardous energy refers to any energy that, when unexpectedly released during equipment service or maintenance, can cause serious injury or death to personnel. This stored energy, often hidden in systems, requires control through safety procedures like lockout-tagout to prevent unexpected machine startup or energy release and ensure worker safety. There are many types of hazardous energy that can be found in the workplace, depending on the facility or industry. They include electrical energy, energy from electrical charges or currents that can cause shock or electrocution. Mechanical energy, energy from moving parts or objects, including kinetic energy from motion, potential energy from tension, or stored energy in springs. Hydraulic energy, the energy of pressurized liquids, often found in accumulators or hydraulic lines. Pneumatic energy, the energy of pressurized gases, such as air in tanks and lines. Thermal energy, energy from high or low temperatures, which can cause burns or other heat-related injuries. Chemical energy, energy from chemical reactions that can cause dangerous situations like fires or explosions. Gravitational energy, potential energy from the position of an object due to gravity, which could cause objects to fall. Nuclear energy, energy released from nuclear reactions. Radiation energy, energy from sources like lasers or ionizing radiation that can cause various health effects. And stored energy, any residual or stored energy within a system that is not being used but can be released unexpectedly, such as energy in batteries or capacitors. An energy isolating device is an applied device that physically prevents the transmission or release of hazardous energy. These devices are essential for lockout-tagout procedures, ensuring that machinery remains inoperative and safe for workers during maintenance, inspection, or installation by physically holding or blocking energy sources. They include electrical devices, such as circuit breakers. Manually operated circuit breakers can be used to interrupt the flow of electricity, preventing electric shock. Disconnect switches. These switches disconnect electrical conductors from their power supply, providing a physical separation of energy. Fuses. While sometimes used, fuses are a single-use electrical device that interrupts a circuit by melting, though a disconnect switch is often preferred for lockout-tagout procedures. Mechanical and hydraulic devices including line valves. These are used to shut off the flow of fluids or gases in pipes, isolating the system from hydraulic or pneumatic energy. Blocks. Used to physically block or prevent the movement of machine parts, which is crucial for isolating mechanical energy. And other types, that can include blind flanges. A solid disc that is inserted between two pipe flanges to physically close off a line and block the flow of chemicals or other hazardous materials. Wedges and pins. Specialized devices used to physically restrain the movement of parts in hydraulic or pneumatic systems. And restraints. Any device that prevents parts from moving, such as chains or special locks, can be used to isolate energy. There are devices that are perceived as energy isolation devices that do not actually remove the energy source. Some common misconceived energy isolators are control switches. Devices like push buttons and selector switches are not energy isolating devices because they only control the flow of energy but do not physically stop it from being transmitted. Control panels. Similar to control switches, panels are for managing energy, not for isolating it during a maintenance or repair task. And tagout devices. While often used with lockout/tagout devices like tags and locks, the isolating device itself is the mechanical component, not the tag or lock. The physical lockout devices prevent the machine or installation from inadvertently being reactivated while work is being performed. The four main types of energy lockout devices are padlocks. They are the most common type of lockout-tagout device and are designed to physically prevent an energy source from being operated. These are personal locks used to secure an energy isolating device. Each worker has their own designated lock to ensure accountability. Hasps. They have multiple holes, enabling each team member to attach their own lock. This ensures that no one can re-energize the equipment until all workers have completed their tasks and removed their locks. Hasps allow multiple workers to apply their individual locks to a single energy source. Valve lockouts. They physically secure the valve in a closed or safe position, stopping the flow of potentially hazardous materials. They are specifically designed to prevent the operation of various types of valves. And electrical plug lockouts. These devices cover the plug or cord, securing it in a way that makes it impossible to plug it back in during servicing or maintenance. The purpose is to prevent the accidental reconnection of cord and plug-connected equipment to a power source. Lockout-tagout involves three primary roles with specific responsibilities and training requirements to ensure safe lockout-tagout operations. They include authorized employee. This is a trained individual who is authorized to perform lockout-tagout procedures because they recognize hazardous energies and have the knowledge to safely lock and tag out machinery for service or maintenance. Affected employee. These are individuals who work in the area where the lockout-tagout procedures are being performed. They are not performing the lockout-tagout but are trained on the procedure and understand that equipment in the area is locked out for safety. Lockout-tagout coordinator. This role involves overseeing the organization's lockout-tagout program, ensuring compliance with safety regulations like those from OSHA, training employees, conducting audits of procedures, and maintaining records. And qualified employees. Those who are knowledgeable in the operations of the equipment, along with the associated hazards. A qualified employee may work in conjunction with the authorized employee to perform lockout-tagout procedures. Energy isolation methods involve physically disconnecting and securing machinery from its power sources to prevent unexpected startup or energy release, using devices like circuit breakers, disconnect switches, valves, and blocks, and is primarily implemented through lockout-tagout procedures to ensure safety for workers. The key steps of isolating energy in preparation for work include 1. Identify energy sources. Determine all potential sources of hazardous energy, including electrical, mechanical, hydraulic, pneumatic, chemical, thermal, and gravitational energy. 2. Shut down equipment. Turn off the machine or equipment using its standard operating procedures. 3. Isolate energy sources. Disconnect the equipment from its power source using appropriate energy isolating devices, such as closing a valve or flipping a circuit breaker. 4. Apply lockout-tagout devices. Use a personal lock and a warning tag on the isolating device to physically secure it in the off or isolated position. 5. Release stored energy. Drain residual energy, such as pressure in pneumatic or hydraulic lines, and discharge any stored electrical energy in capacitors. And 6. Verify isolation. Before beginning maintenance, test the equipment using the operating controls to ensure it cannot be started and that all energy is indeed isolated. Lockout-tagout devices are removed by the authorized employee who installed them. After ensuring all personnel are clear, tools are removed, and the machine's operation is intact. Affected employees are then notified before the machine is re-energized. In special circumstances, an employer can authorize forcible removal if the authorized employee is unavailable and the company's energy control program includes specific procedures and training for this scenario, though the authorized employee must be notified. The steps for lockout-tagout removal are: 1. Inspect the area. Ensure all non-essential tools and materials are removed from the work area. 2. Inspect the machine or installation. Check to make sure all parts of the equipment are operational and that all personnel are safely positioned away from the machine. 3. Inform affected employees. Notify all affected personnel that the lockout-tagout devices are about to be removed and that the machine will be reactivated. 4. Remove devices. Each authorized employee removes their own lock and tag from the energy isolating devices. And 5. Reactivate the machine. Restore energy to the machine or installation. Group lockout procedures give the same level of protection when multiple authorized employees need to work together to perform maintenance or service on a piece of equipment. A key part of the process is to designate a single responsible employee who is in charge of lockout-tagout and is accountable for the overall procedure. Each authorized employee must apply their lock to the points of isolation on the machine to ensure the equipment cannot be re-energized until every employee has completed the work and is in a safe location. These rules will be reviewed with all authorized and affected employees by the group coordinator before the lockout. Each employee will affix their lock to the equipment being serviced. No employee will be allowed to remove another employee's lock. Each employee will remove their lock when their part of the operation is complete. When servicing or maintenance involves more than one shift, the off-going shift will remove their locks as the oncoming shift applies their locks. And when equipment has only enough room for one lock, the group coordinator will place the lock on the equipment and then place the key to that lock in a cabinet or box. Each authorized employee will then affix their lock to the cabinet or box. During shift changes or when the authorized employee currently performing the repair must leave before their replacement arrives, the replacement shall place their lock on the equipment and then the authorized employee will remove their lock. If the replacement employee is not present during the time that the current authorized employee is preparing to leave, the replacement employee will place their lock on the equipment and then a representative for the current employee will remove their lock. And if a lockout person leaves with their lock in place, management must initiate an emergency lock removal procedure, which involves verifying the employee's absence from the facility, attempting to contact the employee, and if unsuccessful, authorized personnel can remove the lock. This removal must be documented, the employee notified, and they must be informed of the removal before resuming work. An organization must have a lockout-tagout program that governs identifying and isolating all energy sources, such as electrical, mechanical, and hydraulic, to a machine or equipment, applying lockout and tagout devices, dissipating any stored energy, and verifying that the equipment is isolated and safe for servicing or maintenance. The requirements include written procedures. Establish specific, written procedures for controlling hazardous energy for each piece of equipment, including its energy sources and isolation points. Energy control devices. Use locks, tags, and other devices to physically secure energy isolating devices, preventing unauthorized startup or release of energy. Training. Train authorized employees on how to identify energy sources, implement proper lockout and tagout steps, and understand job-related dangers. Periodic inspections. Conduct annual inspections of the energy control procedures to ensure compliance and effectiveness, with an authorized employee other than those using the lockout-tagout being the inspector. And documentation. Keep detailed records of all lockout-tagout related actions, including equipment, dates, and personnel involved. To comply with OSHA regulations, employers must implement and sustain a lockout-tagout program. The components must include procedures. Develop, document, and maintain specific energy control procedures tailored to the facility. Provide initial training. Before employees begin maintenance or service work, they must receive training on the applicable procedures. Certify training. Employers must certify that training has been completed. Retrain, as necessary. Retraining is required when there are changes in job assignments, equipment, or procedures, or if periodic inspections reveal inadequacies in the procedures or employee knowledge. Inspections. Lockout-tagout inspections require a periodic review of each energy control procedure at least annually to ensure it's adequate, understood, and followed. And documentation. Employers must document the identification of each machine, the dates of periodic inspections, and the names and training dates of authorized employees to certify their training. The implementation and compliance with the Lockout Tagout program is key to preventing energy-related injuries in the workplace. We hope you found this training valuable. Please click the subscribe button to access additional food shore training videos.